We want to solve the following equations, giving answers to three significant figures where appropriate. The first equation is 3 to the x equals 17. We can solve this type of equation by taking log of both sides of the equation. It doesn't matter whether you take logs to the base 10, logs to the base e, or logs to any other base, although since most calculators only do logs to the base 10 and logs to the base e, it makes sense for it to be one of those two bases. Once we've taken logarithms of both sides, we can start to work with the equation. We can use our log law here to write this as x times log 3. This is equal to log 17. And then dividing both sides by log 3, we get x is equal to log 17 divided by log 3. And this calculates to give us 2.58, correct to three significant figures. Part B here can be done in the same way. Take the log of both sides, so we get log 3 to the x plus 1 is log 9 to the x minus 1. We can use our log law to bring the index down in front, and it must go into a bracket here, and the same on the other side. We can expand these brackets in the normal way. On the left, we'll get x log 3 plus just a single log 3, x log 9, take away log 9. We need to get the x's together and the numbers together. So if we bring all the x's to one side, we get x log 3, take away x log 9, and getting the numbers together, we've got minus log 9, take away the log 3. We can take out a common factor of x here, giving us x log 3, take away log 9, and on this side we could take out a common minus 1, giving us log 9 plus log 3 in the bracket. Now dividing both sides by log 3 minus log 9, we get x is minus log 9 plus log 3, all divided by log 3 minus log 9. If we calculate this, we find the answer is 3 exactly. We need not have solved this equation using logarithms. We know that 9 is equal to 3 squared. So we could have rewritten this equation as 3 to the x plus 1 is equal to 3 squared to the x minus 1. The indices must be the same here, so x plus 1 is equal to 2 times x minus 1. Therefore x plus 1 is 2x minus 2, and this gives us that x is equal to 3. However, in general, this won't happen, and we'll need to use a method like the one that we did first. We can only use the second method because 9 is a power of 3. As a further example, consider this one. 11 is not a power of 3, so we can't do anything using indices directly. We would have to solve this one by taking the log of both sides. If we do that, we get log of 3 to the 2x plus 1 is equal to log of 11 to the x plus 2. Using our index law, we get 2x plus 1 times log 3 is equal to x plus 2 times log 11. Expanding the brackets, we get 2x log 3 plus a single log 3 is equal to x log 11 plus 2 log 11. Bringing the x's to the same side, we get 2x log 3, take away x log 11, and the numbers to the same side gives us 2 log 11, take away log 3. Taking out the common x, we get 2 log 3, take away log 11, and on this side we have 2 log 11, take away log 3. Dividing both sides by 2 log 3 take away log 11, we get 2 log 11 take away log 3 divided by 2 log 3 take away log 11. We can calculate this and we get minus 18.4, correct to 3 significant figures.